So good day everyone. As a continuation of the topic for the measures of dispersion, I will be discussing about the alternative solution that can be obtained. Okay, for this topic, we have an example here, which is to consider the following two sets of data of engine life. So we have to find the standard deviation for each engine manufacturer. So we have two engine manufacturers, which is company A and company B, with different values. For the solution for the company A, as you can see above, if you have your calculators, please compute with me. So for the step 1, we need to compute the mean of the data set. So using the formula for getting the mean of the data set, and then putting the values there from company A, which we have 500 plus 500 plus another 500 plus 1,500 plus 1,500 plus 1,500, and we have 6 values, so we have to divide it into 6. So we will compute that. So 500 plus 500 plus 500 plus 1,500 plus 1,500 plus 1,500 is equals to 6,000. So 6,000 divided by 6, we have 1,000. So for the step 2, as you can see, we have a table over here. And for the step 2, we need to subtract the mean. So the mean is 6,000. So we need to subtract the mean from each of the value in the data set. So we have 500 minus 6,000. Oh, sorry, 1,000 I mean. So we now have 500 minus 1,000, we have negative 500. And another one, 500 minus 1,000 is 500. And for the another 500, that's the same thing. And as for the three 1,500s, it will have the same value. For the second table, we have 1,500 minus 1,000 is 500, and that goes on until the last value. So for the third step, we have also the third table. Okay, so how do we get the values over there? So we need to square the values in the second table. We have these, the 3 negative 500s and the 3 positive 500s. We need to square them and we need to get the sum. So first we have to square these values. So negative 500 squared is 250,000, and that goes on until the last value because they all have the same value. You can compute that to check. So we need to get the sum. So 250,000 plus 250,000 plus another 250,000 and another 3. Let's compute that. So the sum is 1,500,000. So since we're done with our table, we all have our values set, so we have to go to our step 4. So step 4 is to solve for the variance and the standard deviation. So I have placed here the solution and also the formula that will be used. So we will write down the formula. That is equal to the value or the sum, the last table that we have done, we have summed up all its values, which is 1,500,000. We will put that to solve for our variance and the standard deviation. So 1,500,000 is divided into 6 minus 1. So that would be 1 million 1,500,000 divided by 6 minus 1 is, wait, that would be 300,000. So that is our variance. And for our deviation, we will also use the same formula. So we have 1,500,000 minus 6 divided by 6 minus 1 is equals to 300,000, right? So we have to, so the difference between the variance and the standard deviation is that for the standard deviation, we have to 100,000 oh wait, 300,000. So we have 547.72. So we need to get the square root for the standard deviation. That is the difference from the variance and the standard deviation. So now, because we now have the value for the company A, we will proceed to our second example. We will use company B's values. So for our second example, we will use the values from the second engine manufacturer. We have company B. So using the same formula that we use for company A, so first you have to compute the mean of the data set. So of course, you need to put all the values there. We have 925, 3 925s, then 3 975s. So we also have 6 values. So we will divide it into 6. But first, we need to sum up all the values. We have 3 925, 925 plus 925 plus 925 plus 975 plus another 975 plus another 975 is equals to 5,700. And now we will divide it into 6 because we have 6 values. So 5,700 divided into 6 is, we have 950. So our mean is 950. So for the second step, we have to subtract the mean from each of the value in the set. So 925 minus 950, we have negative 25, and that goes the same for the two same values for the 925 under it, and for the 975, for the 975, since we have 3 same values, we have 975 minus 950 is equals 25. So for the next step, we have to square the values in the second table to get the sum. So negative 25 squared is 625, and that goes on with the same values for negative 25. And for the positive 25, for the 3 positive 25, we have positive 25 squared, so we have the value 625. So for the third table, we have the same values for the 6, and so we need to sum it. So to sum it, we just need to add all these values. So 625 plus 625, 625 plus 625 plus 625 plus 625 is 3,750. So for step 4, so for our final step, we need to get again the variance and the standard deviation. So using the same formula, we have 3,750 minus 6 divided by 6 minus 1, we have 750. And for our standard deviation, as shown below, we have using the same formula, 3,750 minus 6 divided by 6 minus 1 is equals 750. But since it is the deviation or the standard deviation, we need to get the square root. So what is the square root of 750? So if you have your calculators, you can compute it to check. So that is equals to 27.39. Okay, so we have come to the conclusion that even though Company A's engines last 50 hours longer on average of Company B, but looking at the respective standard deviation, which we have Company A has a standard deviation of 547.72, it has a higher deviation, or the data is spread widely compared to Company B, which we have the standard deviation of 27.39. So Company B's engines may be the better choice. So of course, there are many other factors such as cost that need to go into the decision. The standard deviation just shows a difference that the mean just cannot show. So we can also use the concept of relative dispersion in this data to compare the scatter of one distribution with another. So for the relative dispersion, so first, what is relative dispersion? So measures of relative dispersion are unitless. They are unitless and it is used when one wishes to compare the scatter of one distribution with another distribution. So how is coefficient variation a part of this? So coefficient variation, so it is also known as relative dispersion. So it is the ratio of the standard deviation to the mean and is usually expressed in percentage. So that is what we have to remember when getting the CV, or the coefficient variation, or the relative dispersion. So it is usually expressed in percentage form. So what is the formula for CV? So it is computed as CV is equals S divided by the sample mean. So the S is the standard deviation. So we need to divide it to the sample mean. Okay, for Company A, since we have all the values settled above, So we will use the formula CV is equals the standard deviation divided by the sample mean. We have for the company A, CV is equals to the standard deviation 547.72 divided by 1,000, since our sample mean for company A is 1,000. So we just need to divide it. 547.72 divided by 1,000 is equals to 0.5477, or of course, since it is expressed in percentage form, it will be 54.77%. So it's as simple as that. That is how we get the coefficient variation. So for the company B, using the same formula, it's equals, their deviation is 27.39 divided by their sample mean, we have 950. So we will divide it and we will get 0.0288, or in percentage form we have 2.88%. So we have come to the conclusion that by looking at the coefficient variation of two companies, company A and company B, company A has a large variability compared to company B. Thus, company B data are spread not too far from the mean. So that is for the relative dispersion. So for our last topic, we will talk about population variance and population standard deviation. So we have an example here on how to compute the population variance and population standard deviation. So for example, so the monthly income of the 5 research directors of Recoleto schools are, we have how many values? 1, 2, 3, 4, 5. So yes, we have 5 values. We have 55,000, 59,000, 62,500, 57,000, and lastly we have the 61,000. So we need to find the variance and the standard deviation. So it goes the same process as we have discussed earlier, but then at the end we just have a different formula. So we need to we also need to create a table for this one to get the values set, so that we can compute for the variance and standard deviation later. So for the first table, we have familiarized ourselves. So it consists of the values. So we have 55,000, 59,500, 62,500, 57,000, and 61,000. So we will write that in the first column of our table. For the second, we will subtract, right? We will subtract the values, the mean from the values. So our mean is, 55,000. So we first have to compute for our mean. So we have 55,000. I have to use my calculator. 55,000 plus 59,500. 59,500 plus 62,500. 62,500 plus 57,000, and our last is 61,000. Oh, sorry, 61,000. So we have 5 values, right? So we have 295,000 divided by 5. So we have 59,000. So 55, okay. So our mean is 59,500. So we will check if we have the correct mean, because I did not include it in the solution. So 59,500. Okay. Oh, okay. We just have 59,000. So we will subtract the mean from the values. Okay. So our mean is 59,000, right? So 55,000 minus 59,000 is negative 4,000. For the second one, 59,500 minus 59,000 is 500. For a third value, we have 62,500 minus 59,000 is 3,500. And next, we have 57,000 minus 59,000 is negative 2,000. And for the last value, we have 61,000 minus 59,000 is 2,000. So for the third column for the table, we will square. So negative 4,000 squared is 16 million. And 500 squared is 250,000. And another, we have 3,500 squared is 12,250,000. Negative 2,000 squared will be 4 million. And positive 2,000 squared is 4 million. So we will get the sum. So please compute with me if you have your calculators with you so we can check. So 16 million. 16 million plus 250,000 plus 12,000, 12,250,000 plus 4 million plus 4 million is, we have 36,500,000. So now that we have all our values set, we will compute for the population variance and the population standard deviation. For the population variance, that will be, okay, this one. Okay, so I have placed it in, as you can see it, I've placed it in the slide. So we will use the first formula, that would be for the population variance. So for the population variance, we will use that formula, that is equal to 36,500,000, and we have to divide it to the number of our values. You have 5. So 36,500,000 divided by 5 is 730,000. So that would be our population variance. So it's as easy as that. So for the last one, for the population standard deviation, so how do we compute it? So we use the same formula. So 36,500,000 divided by 5 is 730,000, right? So again, for the standard deviation, so it goes the same for also the population standard deviation, we will get the square root. So what is the square root of 730,000? So we have 2,701,85. So that would be the end of our lesson for today.